So in this tutorial we are going to see some more problems on formulating the linear programming problem. Let's see this program or the problem. A person wants to decide the constituents of a diet which will fulfill his daily requirement of proteins, fat and carbohydrates at the minimum cost. The choice is to be made for 4 different types of foods. The yield per unit of these foods are given in the table, and formulate this linear programming model. So as you can see in the table, many of them they will directly write like the three products are protein, fat and carbohydrates, and they will write like this, like 3x1 plus 2x2 plus 6x3 less than or equal to 45. Like that they will get confused and they will write, since the values are given in the RHS, they consider this as the RHS, and they will consider this as the objective function, like z is equal to 800, 200 and 700. But when you see this problem carefully, here the term minimum requirement is given. Whenever they have given the minimum requirement or the maximum requirement, it should be come in the right hand side. If the problem is given with a minimum requirement, then the problem is said to be a minimization problem. If they have given maximum availability or the maximum requirement, then the problem is said to be a maximization problem. So here the given problem is minimum requirement, so the problem is minimization problem, and the constraint is given like this. Okay, so now what you can see is this will be the profit or the cost per unit. So whenever you see the cost per unit or the profit, you can consider that as the objective function. So we can reframe this objective function as 45x1 plus 40x2 plus 85x3 plus 65x4, and the constraints are 3x1 plus 4x2 plus 8x3 plus 6x4, which is greater than or equal to 800, because we are dealing with a minimization problem. Similarly, 2x1 plus 2x2 plus 7x3 plus 3x4 greater than or equal to 200, 6x1 plus 4x2 plus 7x3 plus 4x4, which is greater than or equal to 700, where x1, x2, x3, x4 are strictly greater than or equal to 0. So the thing we have to see here is, if you are seeing any term with a minimum requirement, it should become at the RHS of the constraint for the minimization problem. If it is a maximization problem, you can see like maximum requirement. If you can see profit or cost per unit, it should comes under the objective function. So it is represented as 45x1, 40x2 plus 85x3 plus 65x3. You should not confuse. So many people or many students, they will write like this, like 800x1 plus 200x2 plus 700x3 as the objective function. It is wrong. So in this way they will interpret the question. So you have to see the keywords and you have to write. So we will move on to the another type of the problem, where a film produces an alloy having following specification, where specific gravity is given less than or equal to 0.98, chromium it is greater than or equal to 8%, melting point is greater than or equal to 450 degrees Celsius, and raw materials are A, B, C and etc. And they have given a table. So what you have to do is, again this problem will be a very confusing problem. So many they will write like this, 0.92 x1 plus 7x2 plus 440 x3, like that, because the product like A B, they think that the properties like A B C, like that they will think. But when you carefully read this, the cost for various raw materials per ton are 90, 280 and 40 they have given. So whenever you see the cost of various raws, like in a previous problem cost per unit, so whenever you see cost per unit or profit, so that comes under the objective function. So A comes under the objective function, 90A, 280B and 40C. What you can say is, after identifying this as the objective function, we can easily frame the constraint, like so 9.92 x1 or 0.97 x2 plus so that is 1.04 x3 less than or equal to 0.98. So here it is like given in the form of A, B, C, or you can use x1, x2, x3 like I have said. So for chromium it is like 7A plus 13B plus 16C greater than or equal to 8. For the melting point it is 440 degrees Celsius, 490 degrees Celsius and 480 degrees Celsius. So it is written. And the right hand side constraint is directly given 0.98 less than or equal to type, then greater than equal to 8, then 450 which is greater than or equal to. And to identify this as the maximization problem or minimization problem, they have given at last they have given the cost of the raw material is minimum. That means the problem is minimization problem. So you will be getting the constraint of type greater than or equal to, but in the question itself they have given the constraint type. You can directly put that as the constraint type. For the first one less than or equal to, for the second